All right, here we go. We're moving on now to the last leg of the semester, and we're getting into that fundamental theorem of calculus that we talked about at the beginning. It actually starts showing up now in chapter 5, but section 4.08 leads into it in kind of a cool way. And one of the ideas is the concept of antiderivative. One of the things I want you to get the gist of is thinking about the process of the word antiderivative. Okay? Antiderivative. What is the opposite of taking a derivative? And it's the opposite, So for as an example, what did I have to take the derivative of to get 2x? If the derivative is equal to 2x, what was y? What did I have to take the derivative of to get 2x? I think it's a good one to start with because it's kind of obvious. It's one of the easier ones that we've worked with. But you get the idea that, we had to bring the power down by, subtract 1 up on the exponent. You had to bring the power down. So it had to come from x squared, That's the general idea. If y is equal to x squared, then y prime is 2x. That is the general idea, right? And so if you're given 2x, the antiderivative is where did it come from? What did you take the derivative to get that? All right? And that's kind of the general scenario of the process. That's the logic of what antiderivatives are about. Where you can always think about that. Where did it come from? Okay? All right? And the notation that we start using is that they use a little lowercase f to represent the function that you're asking the question about. What did I take the derivative of to get this? And then, so it came from something with the bigger power kind of thing. They use a cap f to represent the antiderivative. Okay, the cap f is antiderivative. Little f, lowercase f, is the derivative of cap f. So the way they work with things and define it, they say that the definition of antiderivative is cap f is called antiderivative of f, antiderivative of f, little f, lowercase f, if f prime of cap f equals little, lowercase f. It's got to work for all x. It's got to work for everything, okay? So cap f is the antiderivative of lowercase f if the derivative of cap f equals lowercase f, all right? That's a key part of it. Now listen, one of the things that's kind of important to get with this is that, yes, it's obvious, the derivative of x squared equals 2x, okay? Well, what if I had the cap f was equal to cap f of x was equal to x squared plus 1. Okay, what's the derivative of that? All right, well, the lowercase f, which is cap f, the derivative of cap f, is equal to, again, you get 2x, okay? Plus the derivative of 1 is 0. So the derivative of x squared plus 1 is also 2x. So the derivative of x squared is 2x, and the derivative of x squared plus 1 is 2x. Well, what about negative 7? What if cap f of x was equal to x squared minus 7? Lowercase f is equal to that. You got to make sure you distinguish now that cap f and lowercase f. The derivative of cap f is now 2x. What if it was 1,000,000? Huh? Doesn't matter. The derivative is going to be 2x. No matter how big or whatever that number is, f prime of x is equal to 2x. So one general way to discuss this is you're going the other direction. You got to remember that there's some number you don't know what you took the derivative of to get here. So if you start with 2x, so if I have lowercase f equals 2x, the notation we use is that the cap f, we know for a fact, had to come from x squared. But then there's this constant that could have been there. And the way we generally talk about that is cap c. So that's just this constant. That means this is called the general antiderivative. So cap c stands for any possibility that could be there. There could have been something, we don't know what it is, okay? So that's a general rule of thumb that you need to recognize when you're asked for a general antiderivative. You got to remember the plus c. Got to make sure you have that, okay? Well, let me ask you another one. What if the lowercase f of x equals e to the x? What did I take the derivative of to get e to the x? Ah, yes, e to the x. So it turns out that cap f of x is also e to the x, because you take the derivative of e to the x, you get e to the x. But we got to remember now, there could have been some constant being added to that. So if lowercase is e to the x, then cap f is equal to e to the x plus c. Let me give another one. What if I had this? F of x, little lowercase f, 1 over x. What did I take the derivative of to get 1 over x? Yes, I heard 3 of you, ln of x. No, there were more of you than that. Your voices were all in harmony. That's the only thing there. Your thoughts were in harmony. But yes, that's correct. It's cap f of x equals the natural log of x. It's really critical, though. The natural log has to be a positive value. So absolute value signs around that x is a critical part of a correct answer. And you've also got to remember the plus c. Okay? And let's do one more. I want you to see this, and then I'll move on to the reverse power rule. But the idea of what is, if little lowercase f equaled cos x, what's cap f? What did I take the derivative of to get cos? Yes, cap f of x, you had to take the derivative of sine to get cos. And notice going the other way, you get a negative sign comes into the picture. So if lowercase f equals sine x, you got to be careful with this now. The reverse, what did you take the derivative of to get sine? Well, the derivative of cos gives you negative sine. Well, the situation is that must be then the cap f is equal to negative cos. Okay, x plus c. You got to remember that. Okay, one more thing. Make sure you get that down. One of the other things I want to talk about is the key one that's used a lot is this. So if I had, notice this, if I have x to the fourth, if y equals x to the fourth, what's the derivative of that? What's y prime? Right? Bring the power down front, subtract 1, right? So look at the process I've got to do in order to reverse that. I've got to increase the power by 1. And instead of multiplying by 4, I got to clear that 4 out of there. That means I got to divide by that number that's out front. So you add 1 to the power, that takes it up by 1. And then you got to also divide by whatever that power is so it'll cancel out. So that rule is simply written like this. If lowercase f equals x to some a power, whatever a is, then cap f of x is equal to raise the power by 1, and then you got to divide by that new higher power. All right? So for instance, if I've got x to the third, okay, then what did I take the derivative of to get that? We're going to start getting into some fractions now in this situation. The cap f of x then turns out to be raise the power by 1 and divide by that new power. So that equals x to the fourth over 4. And now notice, if I have y equals x to the fourth over 4, if I take the derivative of that, what do I get? Bring the 4 down front, subtract 1 on the exponent, I get x to the third. So always you can go back and check yourself, make sure you do that. Those are the general rules. We're going to be going over it and repeating it, so you'll get it down. You need to practice those. In section 4.8, they got a little table of all those little f's and big F's that it came from. Make sure you check into that, all right? So this is solid. There's one more section I want to, one more recording I'll give you for section 4.8. Make sure you get that after this, okay? All right, thanks.